again, everyone, and welcome to another edition of Woodpeckers Deep Dive. My name is Jeff Farris. Welcome to the Woodpeckers Model Shop. Today, we're going to take a closer look at Woodpeckers' new joinery sled. I want to show you some details on setting it up on both your table saw and router table. I'm going to answer some questions that have been coming into our customer service department, and I want to give you some tips on the joints you've been asking customer service about most often. Okay, let's get started. First, let's dive deep into aligning the tool to your table saw and router table. Now, with the micro adjuster on here, this tool is capable of producing some amazing joints, but it needs to be carefully calibrated to the cutting tool to give you the results you're going to be looking for. Now, this is all covered in the owner's manual, but some of us learn more from watching than from reading, so I'm going to go over this for the visual learners. Starting with the table saw. Now, we want to be parallel to the blade, and we want the base relatively close to the saw blade. We don't want to get the base too close to the blade because then we have no room for the adjustable table to adjust. I've found that locating the base close to the edge of the table insert to be a good general purpose location. Now, if you have a Woodpeckers at an inch block, this is a good time to grab it. A standard 1, 2, 3 block would work too. As far as that goes, you could use a straight square piece of stock. I've got this block of Padauk cut to a perfect 3-inch cube. Whichever one of these you use, place it against the body of the saw blade. Make sure the block is not touching any teeth. Now, slide the base against the spacer and tighten the machine screws that secure the base to the miter bar. Slide the sled and the spacer back and forth and confirm that the drag is consistent between the front and back of the blade. Adjust it if you need to, and then torque down a little on the machine screws when you've got it just right. In theory, the bearings between the base plate and the adjustable plate keep everything aligned. But just to double check that, I'm going to square the work table to the saw table. Then I'm going to use the 1-inch side of the block to confirm that the table is parallel to the saw blade. Look at that, right on the money. Theory proven. When I talked to the customer service manager to see what people were asking about on the joinery sled, I expected all the questions to be about the fancy castle joint that I did in the product video. Wrong. Everybody wanted more detail on the simple half lap and bridle joint. So that's what I'd like to cover next. Let's start off with the bridle joint on the table saw. The other thing customer service mentioned was some concerns among SawStop owners about hitting the aluminum fence with their saw blade. In the first step of setting up for the bridle joint, I'll show you how to make that a lot less likely. One of the fasteners for the fence is constructed a little bit differently. Once positioned, it prevents the fence from dropping. You can adjust the angle, but you can't move it up and down. So the first thing I'm going to do is set my depth of cut to match my stock width. Now I'll bring the joinery sled up to the blade, unlock the fixed bolt with an 1/8-inch Allen key, adjust the fence until it is clear of the saw blade, and lock it up. You can still adjust the angle, but the fence won't drop down into the path of the blade. Okay, my stock is milled at 3/4 inch, and I'm using an Ultra-Shear 1/4-inch flat top grooving blade. The traditional procedure here is to divide the material in thirds, which is what I'm going to do, but I want the tenon to be just a tiny bit thicker than the bridle walls. If the mortise is spot on 1/4 inch, and the stock happens to be on the heavy side of 3/4, you'll get a tiny wafer when you cut the tenon. Instead, I'm going to use a delve square here to lay out 1/4 inch from each side. and then we'll use the micro adjust to get the blade just on the outside of the line. Okay, now that's about the fourth or fifth time that I've used the phrase a tiny bit. How much is a tiny bit? Well, it's a little more than a hair, but not quite a skosh. Honestly, at this point, it doesn't matter. We're going for a fit, not a measurement. When we get done, I'm going to show you with a pair of digital calipers how much a tiny bit is. But for now, I'm just going to eyeball the blade just to the outside of the line. That's as careful as I need to be at this point. In addition to the pieces for my frame, I have a couple of pieces of test stock that I milled at the same time. We're going to start with the bridle cuts. I'm going to make 2 cuts on each joint with opposite faces on the clamping table. That will make sure that the opening is perfectly centered on the stock. Okay, that takes care of the test board. Now I'll cut both ends of the 2 short sides. Now, while my last one is still clamped to the table, I'm going to adjust the position to cut the tenon. I'm going to go just a little bit too far and come back to the perfect fit by making a few test cuts on my test stock. Now, this is a little too tight. Here we go, just right. It slides together without forcing, but it won't fall apart if you let go. Now I'll cut the tenons on my project stock. Perfect, ready for glue. You'll also notice that the ends stick just beyond the edges ever so slightly. It's really tricky to get this perfectly flush. If they're a little long, it's pretty simple to plane or sand the little ends. If it's the other way around and the edge is proud, you have a lot more work to do. Now I kept one end of my test stock at the next to last setting. This is the one that's just a little too tight. What's the difference between too tight and just right? Too tight is 263. And just right is 257. That's a difference of about 6 thousandths. Divide that by 2 and you're at 3 thou per side, less than the thickness of a sheet of copier paper. So I guess a tiny bit is about 3 thou. Now let's go over to the router table and make a half lap joint. Setting up on a router table is just a little trickier, because the cutter doesn't have a 10-inch wide reference surface to get you close. You're dealing with a single point of contact. I'm going to start by catching the setup block between the base and a 1/2 inch pin that's clamped in the collet. Now I'll align the sled to the edge of the table by eye and check it with a tape. Now I'm going back and forth from the front edge of the base to the back edge of the base and closing in on getting the same drag fit at both edges. You may have noticed that instead of using an actual router bit, I'm using a piece of 1/2 inch drill rod. I don't have to worry about cutting myself, and the surface is completely uniform all the way around. Now you can cut half laps on either the table saw or router table. I'm going to use the router table today to demonstrate the joinery sled setup on the router table, and also to show off the new Ultra-Shear variable helix joinery bits. To make half laps, you need a router bit with a cut length equal to the width of your stock. The Ultra-Shear variable helix joinery bits are designed specifically for mortise and tenon joinery, and they're available in longer cut lengths. I'm using a 2-inch cut length, 1/2-inch diameter bit on material that's 1 3/4 inch wide and 3/4 of an inch thick. I'll start by setting the depth of cut to match the stock width. Next, I'll scribe a center line on the stock. I'll clamp the stock into the joinery sled and set the table position to cut about 3/16 of an inch. Now I'm going to run all the stock through at that setting. Next, we'll make a second cut that's just a tiny bit short of the center line. Finally, I'm going to sneak up on the perfect fit by making small adjustments to the work table until 2 cuts match up on the faces perfectly. I just love the feel of the micro adjuster and the way the bearings keep the adjustable base perfectly square to the fixed base. Okay, we've got the cut perfect. Next, we'll make the final cut on all of our actual pieces. There we go, ready for glue and clamps. So which of these is a better joint? Well, the half lap is slightly simpler to set up and cut, but the bridle joint has better mechanical strength and twice as much glue surface. It'll hold together, and this one won't. They both belong in your bag of tricks, and with the joinery sled, they're quick and easy. But that's just the beginning of what you can do with the joinery sled. It cuts long miter joints that are beyond the adjustment range of a miter gauge. It's great for cutting sliding dovetails. I mentioned castle joints when we first started the show, and there's so much more. Anytime you need precision control of the positioning of a cut, you can count on the joinery sled. We hope you enjoyed this edition of Woodpeckers Deep Dive. If you did, please give us a thumbs up. And if you haven't yet, please subscribe to our channel and hit the notification bell. That way you'll know about every one of our great videos right when they come out. Thanks again for watching. We'll see you next time on Woodpeckers Deep Dive.